Well, now let's begin looking at the graphs of logarithmic functions. And when we do, we're going to describe its domain, its range, its intercepts, its asymptotes, end behavior, and where the function is increasing or decreasing. And so we've got two logs we're going to graph here. The first one is h of x is equal to the log base 2 of x. And then we'll look at j of x, where that equals the log of 1/3, base 1/3 of x. And I'm first going to actually put this in the calculator and graph it, just to make sure we know how we can graph that as something other than log base 10 or the natural log ln. And then I'm going to take some screenshots of the graphs, and we will then describe the domain, the range, the intercepts, the asymptotes, and the end behavior, and where the function is increasing and decreasing. All right, so here we are on our calculator, and let me clear out what I've got. And I'm actually going to graph 3 graphs here at one time. And first we're going to graph the log base 2 of x. So I'm going to go to the math button. So I'm going to hit the math button. And if I scroll down, I guess I'll scroll down. I could hit second A. Option A is, you see, is log base. So I'm going to hit enter here. And so here I've got log, and I fill in the little box, 2 of x. And that's going to graph my log. Now I'm also going to go ahead and graph the inverse of that, and we know that logs are inverses of exponentials, exponentials are inverses of logs. And if I'm going to graph the inverse, let's see, and that's just to really kind of give us a picture of what's happening with the graph. I got 2 raised to the power of x, 2 caret x. And then I'm just going to graph a linear function in here. It's going to appear in green, which is just y equals x. Again, this is just to give us a good picture of what's happening. So let's see what we got here. Now the blue that's just coming up, that is log base 2 of x. The red is 2 raised to the power of x, exponential function. And then the green is just a linear function. It's just kind of giving us a picture of where this thing shifts over. Now, I'm going to go back to the next screen, and we're going to analyze, in particular, this graph, the one in blue, as to its domain, its range, its intercept, its asymptotes, what else? End behavior, and whether it's increasing or decreasing. All right, so I'm focusing here on my graph. I'm really focusing on the blue. Let's see, if I want to describe the domain. Now, just tell me while I'm here, just as the red, which is the exponential, hovers all along the x-axis, just barely above it, and then shoots up. This blue is actually, if it went on down and you could see it, it's actually going to hover right along that x-axis. It's never going to get less than 0. So my domain then, in this, that's not a good D. Well, what's wrong with my eraser? There we go. My domain is equal to 0 out to infinity. So I see myself headed out to infinity. My range, what's my range going to equal? Expressing my range. Well, it's going, y values are going from negative infinity out to infinity. So range is negative infinity to infinity. Sorry, infinity symbol. Let's make another one. A whole lot better. Let's see, I've got a x-intercept let's see, I got an x-intercept where I got there at 1. I've got an asymptote at the y-axis. Okay, now what about my end behavior? So my left end behavior, let's say is x. Let's say I've got a limit as x is approaching 0 from the left. Then f of x, or y, is equaling negative infinity. And then I've got another limit as x is approaching infinity, f of x equals infinity, or y is equaling to infinity. And let's see, what about increasing and decreasing? Well, we are increasing. I'm going to move it over here. I'm increasing from 0 out to infinity. Okay. Now, the second graph of the function that we were looking at, we were going to look at the log of 1/3, base 1/3 x. And here we see this in the blue. Now, the fact that that is, and the red, of course, is 1/3 raised to the power of x, the exponential function. But the fact that that base is less than 1, you can see has flipped, if you will, it has flipped this blue graph over the x-axis. So again, let's think about our domain. Well, my domain hasn't changed. My domain is going from 0 out to infinity. And my range, what about my range? What's my range doing? Range. Well, let's go out to negative infinity out here to the right. It's going to come all the way up this, put a different color. It actually is going to come up this x-axis, but never cross it. I mean y-axis, but never cross it. So then my range is still negative infinity out to infinity. I still have an x-intercept at 1. I've got an asymptote again. That's a hard word to spell sometimes. At the y-axis. Now let's see, let's think about the end behavior. So what's happening at the end behavior? So I got a limit as x is approaching 0. So as x is approaching 0, what's happening to y? F of x equals infinity. It's going up to positive infinity. And then we've got a limit as x is approaching infinity, f of x equals negative infinity. And then increasing, decreasing, we are decreasing from 0 out to infinity. X values we're talking about, going from 0 out to infinity. All right, well, that's taking a look at some graphs of logarithmic functions. We're actually going to look now next at some transformations of logarithmic graphs, and I believe we're going to use the natural log to go about doing that. So hold on, more fun's coming.